Alright, I think we're live. How's it going, everyone? Hopefully y'all are doing alright, even at this hour. The stream is definitely a little bit later than usual, but yeah, it's been a pretty tiring day. I don't really have too many concrete plans for today, so yeah, we will just be day 35 doing question mark, I suppose. Yeah, I mean, the leetcode's never gonna change, so we're gonna do that, and then I might do a little bit of planning work for next steps in the project, because I think we've covered the main pile of interesting things for the current amount of it we have built up. What's good, Niraj? Welcome to the stream. Okay, leetcode. LeetCode never changes, LeetCode never ends. Just gotta keep the grind going. Okay, here we go. Path functioning keyboard, blah blah blah. Broken letters. Okay. So then each word is just, okay, sure. Alright, well, this problem seems a little bit straightforward. We'll just make an array of char. Actually no, array of int, I guess, for the letters there are. And broken letters length is 26 at most, okay. So this will be cannot. What would we call this? Broken, I guess. I thought it'd be easy until I remember you have to optimize it, yeah. I don't know, I feel like I don't really want to write more passes for now. I want to just get it to a point where I can generate code first, so then I can maybe do a little bit of like benchmarking. Or at least just like generate like real programs. The other thing that I'm thinking about, let me write this for loop real quick. Broken letters. Yeah, the other thing that I'm thinking about is, it's gonna be really annoying to add more things incrementally, because I would have to modify every level of the compiler. So what I'm thinking is maybe it would be easier if we at least added like control flow first, with like if statements and then fee instructions, and then from there we can validate everything up to the current point works. And then we can do bool for this. It just occurred to me. I could even do a bit set anyway. Yeah, I think it might be easier to get everything working, and then from there just handle most of the backend stuff at once, because then everything else is like relatively small additions that are less applicable across the entire range, I guess. Maybe I'll add like memory operations. That might be simple. That might be relatively simple because I already have like allocate and load store. I just have to change the way that types work, I guess, but that's no big deal. C++ bit set. Let's see if I can use bit set instead. Let's go to Africa. Loki, I haven't seen you in the chat for a while. Hopefully you're doing all right. Okay, so we want a set. So we want bit set broken. Might be hard to try heap allocator. I don't really care about, I don't think I'll worry about like runtime stuff for the most part for now. Yeah, I think there's at least decent built-in support for a lot of things. I also might just like make a really quick like runtime library, which is a little bit silly. How does that work? Oh, I see. Broken.set C minus A. Yeah, I might just like make a runtime library and precompile that separately because I don't really want to worry about like allocation right now. I care less about the programming language proper and more just about like the code transformations that occur in a compiler for now. I try not to watch streams or TikTok that much. Yeah, fair enough. Yeah. I think like September is like grind time, so that seems pretty reasonable. Okay, so we've processed the broken letters, then let's make a string while, so string stream. I don't remember how this works. So we have cur, and then we want to turn text into a string stream. And then we want stream. Is this how this works? Okay. For each character in cur, we want to, if, let's see. Oh, we can just index this, yeah. It's broken at C minus A. I really want to use like a goto or something. We'd have to use a flag though. Int bool valid 0 or 1, I guess. True. So if it's in broken, then valid is false. And then I also want to have int res equals 0, and then res plus equals, oh, we should put this in here. Yeah, it's a lot of stuff to remember, but once you use more of it, you kind of get used to working with it. Let's do that, and then we can return res. And this should be good to go unless I did the string stream wrong. Oh, god damn it. Oh, it needs a size, huh? Yeah, it needs a size. That's what I'm missing. Size 26. And okay, something is wrong. And then we want to cout valid. Let's just do this to test this one. I think that might be easier. Well, it's not printing anything. It's always 0 as well. Okay, so that means we're not getting this. C++ create words in iString stream? Are you serious? Oh wait, I don't set anything. Okay, I completely bought it out. I'm gonna be real with you. Okay, so we just need to pass the thing into it, I think. Text. Alright, let's see if this works now. There we go. Perfect. Bitmask integer would be the most efficient? Yes, but I honestly don't care enough right now. I'm quite tired. I should probably learn that at some point, but it's whatever. This is slow, interesting. Okay, so we just... okay. This seems incredibly slow, though. So... I guess the string stream... oh, it's string stream... oh, wait a second. Maybe if I do it this way? Let's do text. Let's try it like this. Yeah, okay, there we go. That was the big slowdown there. Okay, neat. Coolio. So leetcode's done. Yeah, I'm not really sure what I want to do here though. Yeah, I don't have anything planned right now. We're kind of at like a pretty interesting intermediate point, I guess. Let's take a look at this for reference. Yeah. I guess I keep deleting the branches as I merge them, but we have a lot of big milestones then at least. We have like the big let's see. We have like the big CI/CD stuff set up, as in just CI, I guess, but we have like the basics of a test runner in here, at least. And that makes those two combined make development just a whole lot less miserable. And then in terms of the compiler itself, we have a front end, we have a middle end. We don't have a back end yet. That's something that we could start. But in the middle end, we also have like a singular optimization that exists, which is pretty cool if I do say so myself. And then the driver is just like the thing that puts everything together. Yeah, maybe some other time I'll do like proper work here, just like building out the CLI parser more, but I think that's somewhat low priority at least. So I think I might do a little bit of planning today actually. Should do the back end of the stream. There's a lot of stuff there, and I'm way too tired to begin to even think about it. There's a lot of steps, at least. So I think it would be smart for me to at least like slow down a little bit this stream, and just kind of take a step back and sort of gauge where everything is at progress-wise, and just like the next steps. I think that'll also make it easier for me to schedule streams in the future, where I don't just have like this sort of awkward limbo time, where there's like where I don't really know what I want to do, but like I still want to at least like do something. That's good, Skittles. I just completed the leetcode, and I think my plan for this stream will it kind of just like what's being said here. Just like do a little bit of planning, figure out what's left for at least for like the foreseeable future in the project. Yeah, what should I call this doc? Okay, nice. Okay. So I guess we could just split it into the 3 levels. And then we could just throw a driver in as well. Why is it called PANNICC? Because I thought it was funny. There's no other reason. There's like some clever acronym behind it that I don't remember off the top of my head. It's like prototype and non-negligibly instructive C compiler or something, but yeah. Alright, I'm gonna pull out the diagram that I usually pull out because I think that'll help guide the whole process. So, big picture wise, we start from C, and then somehow we go to IR, or I guess I call it MIR, and then eventually the goal is to get to x86-64. So that's like the initial inclination. Yeah, that is the acronym. So this is like the overall flow that we're going for. And we can split into front end, middle end, and back end per usual. Just split it like this. Assembly quiz tomorrow. Uh-oh. Yeah, there's a really funny meme I saw. It's like assembly meme. It's like It's not this. There was like a funny tweet somewhere. I vowel. Okay, well, I'm struggling to find it, but there was something pretty funny. It was like, you know what, I'm gonna take a second to find it. This is from one of my classes, so I'm not sure if I'm allowed to like literally stream this, but I'm going to find the slide with the meme on it, and I will share that. It's that class. Surely it's here. Okay. RLWB. No? Okay. Let me just take a snip instead. Yeah, okay, here it is. This was pretty good. I think when I saw it in class, I laughed for a solid, like, half minute. It's pretty good content. Yeah. Rotate left wheel and buy a vowel. Yeah, so we have the good old diagram, we have front end, we have the middle end, and we have the back end. So what we currently have is we have, from source, we have a parser that takes this to the AST, and then that goes to what I call HIR, which is kind of just like a desugared AST. How much time has it been since you start streaming? Well, I guess 35 days. I suppose it's in the title. So this little gap here handles a lot of things. So it's like, it handles like cleanup. It handles scopes. And then just like general desugaring. As in, like, if you've heard of the term syntactic sugar, it's kind of like taking all of the niceties that we have as programmers and reducing them to their constituent parts rather than maintaining the abstraction. So that's what happens here so far. And then this is just like gen, I guess. So we have that so far, and then we also have like the start of an optimizer, opt. In terms of that, we have, the only pass we have so far is mem to reg. So from here, there's a lot of things to do still, to be honest. And don't get me wrong, this is like a lot, and it's a pretty good start, but we're still quite far from our target state, I guess. So I guess I'll start using green to sort of highlight what's missing. Yeah, this is pretty much the point of the stream. Kind of just like making an overall sum. Where it's like overall like state of compiler sort of and planning. Oh, for how long has the stream been going? I started at the start of this hour, so it's been like 18 minutes. Yeah, today I pushed the stream back. That was announced in the Discord, which you should join if you have not joined yet. That's the best place to get notified when I go live. Yeah. Y'all have seen me here. Y'all have heard me give the spiel for a little. Yeah. So I think you're relatively new here. Although I think most of my work previously on stream has been like the kaleidoscope tutorial that LLVM has. So I was kind of just like following the book pretty much, but here is just completely freeform on my own. Okay, so let's see. What are the big features we need to add still? I think there's a lot of stuff we're missing in the front end first of all, so like control flow. Yeah, my mouse handwriting is actually low-key, I don't think it's that bad. So things like ifs, we need loops, we need direct memory accesses. And then I think that's the big pile here that we want. At least in terms of like control, or these two are control flow. We want memory, or at least memory accesses. What else would be nice to have? I guess maybe my props materials from this one class I did take might be a start. I'm gonna try to avoid completely doxing myself, so I'm not gonna like put this up on the stream, but I'm gonna pull up the slides real quick. Yeah, let's see. Save that. Variable assignment. Arrays, I guess, which also fits under memory. So just like, yeah. And then also tensors, I guess. Those kind of fall in the same category. Tensors, tuples, same difference. You get what I mean. Yeah, we definitely need control flow. That is the big thing that it's missing, I think. We need function params. This should be in brackets. Yeah, function params are a really big thing. More types. I might be a little bit chill with the types because I don't want to deal with defining like too many casts right now. Yeah, I'll mess around with that a little bit, but I also might just make like a typecast intrinsic, which will, I guess, compartmentalize a lot of the code gen mess. This also needs continue and then break. That's pretty important. Yeah, we have loops. And then just like other nice things. So like, there's one other big thing. Oh, proper expression handling. That's the other really big one. Because currently, if we have like, if we want like b equals, let's say like a times 3 plus 5, we couldn't do this as one line. We would have to do like b equals a times 3 and then like b equals b plus 5. We'd have to do it like this, which is like really annoying for me in terms of like writing tests. I think this also falls under like generally learning about parsing. I have ideas of how to do it. I've just been kind of holding off on it. So yeah, that will be something that we need to do as well. I think that's also a pretty high priority. I think these 3 are the biggest priorities for now. Because I feel like params will actually not be that hard to implement after we get like more of this built out. We just have to like assume a lot of things. But I also don't think it'd be that difficult anyway, so that might be a nice intermediate step. Parsing seems really annoying, but I also think that's quite compartmentalized, so I could actually unprioritize that. I think control flow is the biggest one that determines the rest of the stuff, that and memory. So there's really good reasons to do a lot of these, and there's really good reasons to not do a lot of these as well. So yeah, I think that's like the big feature list. And then in terms of other cleanup I want to do, I want to rewrite a lot of this. Rewrite. And there's a couple of big reasons. The first one is I want to use smart pointers. I after figuring out MIR and like control flow graph stuff, I've realized that using raw pointers was low-key a mistake. And I think it would help maintainability substantially if I were to use smart pointers for now. Or at least rewrite it to use smart pointers. And that might actually be a pretty easy one. I thought it would be harder than it is, but it turns out it's actually like pretty straightforward. So yeah, I'm not that concerned about that. Yeah. And then the other thing was I want to clean up the namespaces as well, I think, of everything. I think front end, middle end, and back end is like really, really awkward. And I would much rather just have like one big project namespace, and then a namespace for like each of the IRs/AST, and just like generally save myself a lot of misery. I don't really have a good idea on how I would go about doing that, but I think that's like a substantially smaller concern, so I'm not gonna list that out. There's one other thing in the rewrite I wanted to do. Oh yeah, I guess the proper expert parsing exists here. Let's just asterisk that. Okay. Hopefully this is not too unreadable. I'm not sure how it shows up on stream with like compression and all, but hopefully it's like somewhat readable. If y'all want enough of this, or if y'all want this enough, I'll probably just like put it in my Discord somewhere. Who's your favorite coding YouTuber? I quite enjoy the Primogen. I think his content is entertaining. He has pretty good takes on things in general. But I feel like Sylvan Franklin's just really fucking funny. So, yeah, it's between those two. I also think TJ DeVries explains a lot of NeoVim stuff really well. He's a large reason that like I'm kind of still in a lot of optimization or NeoVim optimization brain stuff. Loops will be easy since most loops are similar to a while loop. Yeah, I don't think it'll be that difficult either. It's just like there's a lot of infrastructure that needs to be built out. And that'll also like test whether I did mem2reg properly for basic block related reasons. And just like general control flow graph mess stuff. It also requires me to add like fee statements. So we'll figure that out as we go, but yeah. I'm getting GitHub from Prime, yeah, same. He explains things pretty well, I will say. He's quite goated in that regard. Okay, middle end. I'll get back to this. I need to think a little bit more about what I want to do here, but bottom line is just a lot more passes. And I don't really know a large range of what there is, but yeah. Let's see. So, what's good? Passes overview. Let's look this up. Okay. This seems like a pretty good list to at least start with, or at least some of these. Let's write like a small list here. Inst combine is definitely a must. That's just like the standard folds and stuff. Dead code elimination will be interesting. And then let's see. What do some of these do even? Yeah, let me look once again at some slides. Give me a second. I like bro code for tutorials and PowerGen for entertainment. That's fair. Yeah, I don't really watch too many tutorials nowadays. Actually, I feel like I should probably watch more. but I feel like they necessitate a lot of doing while I watch them. So it feels a little bit counterproductive, or it feels a little bit like I'm half-assing it if I don't do that. Yeah, so this has like, I guess inst combine includes a lot of things like constant propagation, constant folding, and then like simplifying math. So I think that's probably like a reasonable place to start for that. Let's see. What else can I do? We can... Yeah, I like dead code elimination as well. Let's see. Anything else interesting? Copy propagation? I guess. We could also do global value numbering. Let me look this up a little bit more. Yeah, I think that might be interesting. I think this is a pretty reasonable set to begin with. What else? Yeah, apologies if this is a little bit boring. I just don't want to like completely dox myself, so I'm kind of scrolling on my second monitor. A lot of analyses. So transform plus analyses. Okay. Anything interesting in this one? We could do a lot of like alias analysis stuff, but I think this is a good place to start. And then we can do like memory, just in general. We'll just double asterisk that, and then loops as well. That's the other interesting one, I think, for now. Memory, loops. Those are the two categories, and then there's also like more, I guess, like less micro scale. So like more like control flowy stuff. We'll just do others. Yeah, okay. So I think that's a good list for middle end for now. Yeah, I think a lot of these also depend on a lot of analyses as well that I will need to figure out how to implement. And now I think this is it for like what we can do just sticking to these, and this is already a lot. Backend. Oh boy. There's so much to do. There's truly so much. Let me pull up the reference again. We had like a nice slide in our class, I remember, that covered everything. Yeah, okay. This missing pieces slide deck. Whew, okay. Do you think doing stuff like this helps a lot with projects? Usually I don't do this, but I also feel very directionless, so do what you will with that information. I guess in a sense that means it does help, but it's more of a stylistic thing than anything. Okay. So we need to do instruction selection, I think. Right? Right, there's something I'm missing. Is it here? It's not that one. Okay, so anyway, I definitely read something about like data layout, which I want to maybe look into here. And then next would be instruction selection. So this is where we start getting more towards going from this general sort of assembly form to more intrinsics for it, I guess. And then, oh god, there's so much slush. We also need to figure out when we should destroy SSA form. So I guess like SSA destruction somewhere here. So instruction selection, we also need scheduling. I don't know where to put it. Yeah. And then we definitely need like register allocation somewhere here. And then I think finally here we can just do code gen. Oh, we need like people somewhere. People optimization, so like small changes that just aren't caught further up. Just like hardware specific small opt. Should do it here, I think. And we can do like this. Yeah, this graph's getting a little bit messy, but let's do a little bit of ugly stuff real quick. Let's take that. Let's do that. Perfect. Okay. We can take a bite out of this as well. And we can move it up like this. There we go. Perfect. And no one's the wiser. Except for y'all. Y'all know my secrets. Yeah. So we have instruction selection, register allocation. We have people. Optimization. And then finally we have code gen. And then after all of that, we should be like in a pretty stable state, at least. But there's so much to do until that point, and I don't think we're gonna run out of content anytime soon. There's a lot of thinking that needs to happen back here. I guess now wouldn't be a bad time to start thinking about it, so let me just take a bite out of all of this real quick. Let's move it to a separate layer. There we go. Okay, perfect. So we kind of have this on the side as well. Okay. How do we even approach this? how do you even approach dividing this whole mess up into something workable? Let's just make a new thing for this. Okay. Okay. So we have full arrow. This goes to x86. Will this compiler need an assembler as dependency? Yeah, I don't plan on implementing the assembler yet, or the linker for that matter. I might write like a wrapper script for that, and also like similarly, I'm not going to be implementing a preprocessor for now, so that will also fall under just like other dependencies that are necessary. Yeah, I'll probably just write like a runtime library, precompile that, and then like link against that and call it a day. And that kind of alleviates most of the concerns, I think. Okay. Let me compiler tracing. Okay, this is like profiling and that sort of stuff. Yeah, okay. Yeah, so I think just for my own sanity, I think I will simplify this a little bit. I think I will just cover these four. Let me use a different color. These four, and then maybe this. And then I might take a look at scheduling, but that's kind of later on. The big question I think that determines a lot of this is when SSA destruction occurs. I think that will be a little bit annoying to think about off the rip. Yeah. Let's do a little bit of Googling real quick. Let's see. SSA destruction. When? This is not what I want. I like Social Security. Let's see. Ooh, interesting. Da-da-da. Let's see. Lots of stuff here, lots of theory. Let's ask ChatGPT, as usual. When should my compiler destroy SSA form in the backend? Yeah, this is like the big trade-off. After register allocation, interesting. Seems like a little bit messy though, it feels like. Yeah, we do copies. Alright, see you, Niraj. Take care, get some rest. Okay. I think, what is happening? Why is this breaking? Why is my stream breaking? 1 second. Okay, it's YouTube's tripping. Great. I'm thinking reading this makes a lot of sense to me. I feel like I should keep it for as long as possible. I'm gonna look through the book real quick. If it mentions anything about it helping register allocation, I'm gonna keep it, I think. Rastello. Yeah. Standard destruction. Data flow, reconstruction. That one's interesting. Data flow, liveness. Liveness is also really interesting. I just need to read more of this, to be honest. So much stuff to learn about. What's good, Kane? Welcome back to the stream. I'm getting pinged somewhere. Where am I getting pinged? That's where I'm getting pinged. I see. Let me lock in real quick. Yeah, this is a chapter I think would be important for me to read through. Also, this one. If conversion? Oh. Is it possible to post links here? It might just be easier to post it in Discord and ping me. Here we go. Regalloc, here we are. Yeah, I think this will be interesting for me to look at. It will be a little bit different than what I usually do. So I think this might be fun to look at. Yeah. I think it'll be good practice for me. So anyway, yeah. I think that answers that for me pretty much. Yeah. I think I will throw that towards the later half of it. So let's make a couple more IRs here. So I have high IR, mid IR, and then we will have like low IR. And then I will have a register form of that as well. So like LIRR or something. I don't know. I need to make something up for it. So we'll just do like LIR. We could probably just do one on this even. I think most of this stuff kind of handles itself. It's just like rearranging things. They all look very similar to each other. But the big form transformation happens with instruction selection. So let's do this. And then we will call this LIR, I guess, because we have high, middle, and low. We could even do like VLIR, like variables, but I don't really see a point to that. That just seems very duplicative. Okay, let's take a look at this. How you sure? Yeah, there's a funny thing about upsilon if I remember correctly. Because the upsilon character like looks like a join. And then they use like some other Greek character that looks like a fork, which is really funny. Yeah, okay. Memory C++ and worked on WebKit JIT? I see. Okay, that makes sense. Yeah, this seems reasonable. Okay, this makes sense. Yeah, I'm gonna like skim this a little bit. I think I would have to read this more properly. Maybe I'll give this. Maybe I'll keep this for like a chill stream somewhere. Graph coloring, interesting. I guess that makes sense. Just something that isn't necessary. It's part of instruction selection. Huh. Yeah, I guess that makes sense. Yeah, this is what I do. Okay, that seems pretty coherent. Okay, yeah. Alright. So maybe I actually will destroy SSA form earlier on in the backend, which I guess makes a lot of sense. So let's do... How do we do this? We want back IR, and then let's do like... I think we want two different IRs here as well, in a similar fashion as we did back here. So SSA destruction. And then... Yeah, I think splitting it up will reduce the complexity a little bit. Because I don't want to have to deal with like SSA destruction simultaneous to instruction selection. So I guess like this will be low IR, I guess. And then I guess we can turn this into like Let me see if the book defines anything well. Yeah, so a lot of this will not necessarily be very useful, but yeah, that's fine. Yeah, I'll probably read this first to figure out what I want to do with it, at least. I think that would be useful. Because the more I think about it, the more I realize that the gist is correct about just maintaining SSA being a little bit of a mess. I guess that doesn't necessarily mean we need to destroy it immediately, though. It just needs to be able to handle non-SSA. And we can just like treat it as variables. What is this? Yeah, this is not easy to parse on the fly, at least. And if anyone has any ideas with like some semblance of a justification, please put it in chat and I'll take a look at it. Yeah, I think I could probably do it simultaneously, or at least instruction selection and then like formal destruction later. Okay. Way above pay grade? Unlucky. Worth a shot though, I suppose. Okay. Okay, that might be good to read as well. Let's throw it into chat again. How would I go about implementing register? I guess, say destruction simultaneously with instruction selection compiler backend. Let's see if this gives me anything usable, anything somewhat reasonable or even readable. Okay. I see. Yeah. I'm gonna go to the bathroom real quick while I think about this. So yeah, I'll be right back. It'll be like a minute or two. Okay. This is. Alright, I'm back. Give the camera a second. Hello, camera. Okay, we're back. Knowledgeable is a relative term for me. Perhaps is not the best word to describe it. Yeah, okay. So maybe it'd be a little bit troll to, it might be a little bit troll to do SSA destruction simultaneously or concurrently with instruction selection. So maybe the next best thing is just to do instruction selection first. Let's see what it says. Okay. Yeah, this makes sense. How would I handle these? Oh, I see. Okay, yeah. This makes complete sense, yeah. So you can just replace a key with a copy in the predecessor. Okay. Sure. Okay. All right. That might be the sane way to do this. Either that or maybe I could do like a non-SSA sort of other middle end IR. Maybe, sort of. Seems a little bit sloppy. Thank you for calling that out. Oops, my fault. I keep forgetting that happens. Yeah. So, what was I yapping about? Yeah, I was looking through this. Yeah, I guess, I don't need to do SSA destruction and instruction selection concurrently. I can kind of just sequence them. I guess like destruction happens concurrently insofar as like we get rid of fees, but that's roughly it. Yeah. So I was looking through this book because I figured I should probably figure out what destruction looks like, and then it might be a little bit easier to go from there. Yeah, this seems pretty short at least, so yeah. Destruction is eliminating fee functions pretty much, and then coalescing copies. All variables and non-overlapping live ranges, and it's conventional, sure. Okay. Let's see, what else? I'm not sure what's happening here at a glance. I need to read that more thoroughly. After we have parallel copies, need to sequentialize them. Okay. Okay, sure. So I guess we can kind of handle them concurrently, I think. Where the hell I am? Okay. Sorry, I'm frazzled today. I'm quite tired. So, okay. So we have, I guess, SSA destruction. Or it's like fee removal. Plus instruction selection. This was so dumb to think about the backend right now when I'm tired. I should really just I should have just left this as one big to-do, to be honest. Okay, so then maybe like a small scheduling pass or something. Yeah. Let me just pull up the other thing. Alright, this is the reference. Here. So this is done. And then this is done. Maybe scheduling here and then scheduling here, perhaps? No, we need it before regalloc, I think. Yeah, okay. Just insert an arrow here. Let's move this arrow under so I can like read this reasonably. This is also LIR, I guess. Regalloc. And then one more time, and then once more. So I want this to do that. This is maybe like scheduling. This also has people, and then this is. Yeah, this graph looks a little bit stupid, but I promise it's something that at least I can read. This is CodeGen. Finally, okay. So much stuff to worry about, so much stuff to do. Okay, so let's take this giant graph or table chart, and then let's convert it to something that I can make actionable. Driver is a small thing, just like CLI parsing updates. Front end, we want to rewrite with smart pointers, and then add ifs or control flow. So we can do all of the loops, I think. We can reduce them all to kind of the same general form. So we want while for, let's do while, I guess. Yeah, I think that makes sense. It's just a little bit of different orderings. I think this also necessitates adding like a couple of other instructions, but that should be pretty fun actually, to be honest. We want, I think the next priority is actually probably expression parsing, just so the tests don't grow to like an abominable state. Maybe I do that later though, because I think that's bearable maybe. Memory. I was muted earlier, yeah. When I got back from the bathroom, I forgot to unmute, so whoopsie. So what do we need for memory? There's like a whole pile of stuff, I think, that would be interesting. We have load that, and then we also want array index math stuff, which I think handles that roughly. Knowledgeable? No. I don't think I would quite say that ever. Let me think about how we could do this. Let's go to Godbolt. It's getting hella pings somewhere. So heap malloc. Yeah, okay, well, you could do like a malloc and calloc thing. We could maybe have like a runtime library or something. Let me look at a reference. That's not a good reference. This might be a good one. Yeah, this is, I'm not really sure what the API would look like at the C level for allocating things. Maybe I'll just have a malloc and call it a day. Seems a little bit silly though. Yeah, arrays will be quite interesting to implement, at least. Okay. I think we don't. I think we skip thinking about memory for now. The more I think about it, the more confusing this is. So let's save pointers for last, or just like memory / pointers standalone. And then for now, I think arrays are the only interesting thing, sort of, at least in this regard. So yeah. I think that might make a little bit of a mess, but that might be a later issue as well. Going back to this neat little diagram. So we have smart pointers, we have control flow, we've added memory stuff, params, types, and expert parsing. And more types. Okay. I think these are pretty low priority. Also, param seems like kind of trivial to do, so I think it might be smart to get that done sooner than later. I think expert parsing I want to move up though. Also, but these are like kind of, this one's kind of compartmentalized. Maybe I do that later. These would be smart to do sooner because that would that affects basic, or like the middle end and by extension the back end a little bit more. Or sorry, these three. Yeah, I need to think more about this. I think these two are pretty low. I think all of these are pretty low priority relative to the above though. So this will already alone unlock so much, just in terms of like sanity and stuff. So I think that's a good place to start for that. We can bracket all of that there. And then transforms. This one, the big one, is like dominator tree. And transforms, we want inst combine, dead code elimination, copy propagation. I pulled up a Reddit post, right? Yeah. Anything else interesting here? What is the simplify CFG pass? Let's look at this. Yeah, this falls under loop stuff. Let's see, simplify. Yeah, I think we could implement this as well. This seems straightforward enough. Okay. Yeah, so we want to add simplify CFG. Get chat back up. What else is there here? Inst combine, yeah. GVN. Did I add that here? Yes, I did. Okay. We can do that. We can do that. Let's do it like that. Other memory alias analyses. That, and then let's also throw in loop optimizations, etc. so that falls under that. What is this? Yeah, this might be interesting. Allocates into, I see. Interesting. That might make a bit of a mess, so I'm not gonna think about that one. Ind vars. What is this? Oh, I see. Okay. That might be a little bit annoying. What is this? Reassociate might be interesting at least. I think there was a good list of cleanup passes, right? That might be interesting to look at. At least a good list of cleanup passes in the whatchamacallit, the Kaleidoscope tutorial. I think it was in here, right? Or is it under 4? Yeah, here. PVN, reassociate, yeah, that might be good. Let's throw those in. Reassociate should probably go up here or even after this. Above. Let's do that order, I guess. Yeah, I think that's a pretty solid list here. Let's do that. Okay. We can... Reg to mem is really funny to me. Yeah, okay. So that I think is a pretty good set for the middle end for now. And then we just need to get this backend mess working. Oh boy. Yeah, I'm just gonna have this up on my second monitor. That we want, actually, I think that sort of ordering roughly makes sense in my head a little more. So this will be MIR to LIR. And then we want register allocation, LIR to, maybe I make like a separate like register LIR or something like that. Like, or maybe like a variable LIR. That seems a little bit stinky, a little bit redundant. Okay. Yeah, LIR. I think it's fine to just include registers in it. Yeah, okay. And then we want people. Which goes here. And then code gen, which goes from LIR to x86, 64. And then we also want a scheduling pass somewhere. Let's just LIR to LIR. And then this will, we can just like insert this as we see fit. We can even like benchmark that or something. Yeah. So I think that's a pretty good pile, at least, of stuff to do. I think next time I might do a little bit of this front-end stuff, because I think that's a pretty high priority, since it also affects a lot of things downstream design-wise. So, yeah. yeah, I think we've done a pretty good job of planning for today. So yeah. Yeah, I think that's a good place to call the stream for today as well. I'm quite tired and it's been quite a lengthy day. So yeah. Thank you all for watching. Apologies if it was a little bit boring or dry today. Yeah, make sure you like the stream if you enjoyed it. If you didn't, then also fair enough. Leave a comment telling me what I can do better. Make sure you sub to my channel as well. And while you're down there, you should join the Discord. That's the best place to get notified when I go live, get notified about any schedule changes, and chat with other people in my community. And of course, you should connect with me on LinkedIn and add me on GitHub. So yeah, take care, y'all. Take it easy. Thank you all for sticking around and sticking with me.